Welcome to my channel. Please subscribe. IoT Service-Oriented Architecture. IoT, Internet of Things, is a rapidly growing technology that aims to connect various physical devices to the Internet and allow them to communicate with each other. The Service-Oriented Architecture, SOA, is an architectural style that enables the development of flexible and scalable software systems. In IoT, the SOA approach is used to develop and deliver IoT services. IoT Service-Oriented Architecture, SOA, is a way of designing and developing IoT systems that provide services to other IoT systems, devices, and users. The functional components of IoT Service-Oriented Architecture, SOA, are divided into three main layers: the device layer, the service layer, and the business layer. The device layer is responsible for collecting and processing data from IoT devices. The service layer is responsible for providing IoT services to the business layer and other IoT systems. The business layer is responsible for handling the IoT services and making decisions based on the data provided by the service layer. In the device layer of the IoT SOA, devices are responsible for collecting data from the environment and sending it to the service layer. Devices can be sensors, actuators, or any other device that collects and processes data. The device layer can also include gateways, which are devices that collect data from other devices and send it to the service layer. The service layer of the IoT SOA is responsible for providing IoT services to the business layer and other IoT systems. The service layer can include several components, including a service registry, service broker, and service bus. The service registry is responsible for maintaining information about available IoT services. The service broker is responsible for finding and connecting IoT services. The service bus is responsible for routing messages between IoT services. The business layer of the IoT SOA is responsible for handling the IoT services and making decisions based on the data provided by the service layer. The business layer can include several components, including a business process engine, business rules engine, and analytics engine. The business process engine is responsible for defining and executing business processes. The business rules engine is responsible for defining and executing business rules. The analytics engine is responsible for analyzing data and providing insights for decision making. The IoT Service-Oriented Architecture, SOA, enables the development of flexible and scalable IoT systems. It allows for the development of modular and reusable IoT services that can be used by multiple IoT systems and devices. The SOA approach also enables the development of IoT systems that can adapt to changing business requirements and environments. With the use of IoT SOA, businesses can easily develop, integrate and deploy IoT services and systems. IoT challenges. The Internet of Things, IoT, is a rapidly evolving field with tremendous potential for various applications. However, it also presents numerous challenges that need to be addressed to ensure its successful deployment and adoption. Here are some of the significant challenges faced in IoT. Security. As more devices connect to the Internet, the security concerns also grow. IoT devices are vulnerable to cyber attacks, which can lead to data breaches, unauthorized access, and other security threats. Ensuring robust security mechanisms is critical to building trust and confidence in IoT. Privacy. IoT devices collect large amounts of data, some of which may be personal or sensitive. As such, privacy concerns arise when it comes to how this data is collected, processed, and used. The lack of transparency in the collection and use of this data can lead to a loss of trust in IoT systems. Interoperability. IoT devices and systems are developed by different manufacturers and often use different protocols and standards. This makes it challenging to integrate them with other devices and systems, leading to interoperability issues that need to be addressed. Scalability. The number of devices connected to the Internet is increasing rapidly, and IoT systems need to be able to handle this growth in scale. The ability to scale up IoT systems without compromising performance is critical. Reliability. IoT devices are often deployed in remote and harsh environments, where they need to function reliably. The reliability of IoT systems is critical, especially in applications such as healthcare and transportation, where lives may depend on them. Power consumption. Many IoT devices are battery powered, and their power consumption needs to be optimized to ensure that they can operate for extended periods without requiring frequent battery replacements. Cost. IoT devices and systems can be expensive to develop and deploy, which may limit their adoption in some applications. The cost of IoT devices and systems needs to be reduced to make them more accessible to a broad range of applications and users. Data management. IoT devices generate vast amounts of data that need to be processed, stored, and analyzed. Data management is a critical challenge in IoT, and systems need to be developed to handle the large volumes of data generated by IoT devices efficiently. In conclusion, IoT presents numerous challenges that need to be addressed to ensure its successful deployment and adoption. These challenges are complex and require a multidisciplinary approach involving experts in various fields, including cybersecurity, privacy, data management, and engineering. By addressing these challenges, we can unlock the full potential of IoT and create a more connected and intelligent world.